Hello everyone. In this lecture, we'll discuss or study about specific heat of solids. So we'll have basic idea about theory of specific heat of solids. So what is specific heat? Specific heat, how it is defined? It is defined as amount of heat required to raise the temperature of 1 gram mole of a substance by 1 degree centigrade. So if you amount of heat required to raise the temperature of unit mass through unit temperature, amount of heat required to raise the temperature of 1 gram mole of a substance through 1 degree centigrade. 1 degree centigrade is per unit degree temperature. Okay, so suppose we give dq amount of heat and it changes temperature from T to T plus dt, then we have specific heat equal to dq by dt. So if it is per mole, gram mole, then we call it molar specific heat. Okay, now one important thing you should remember here, that the condition under which the rise in temperature due to dq depends on condition under which it is applied or given. এই হিটটা আমরা কি কন্ডিশনে দিচ্ছি তার উপরে টেম্পারেচার রাইজটা ডিপেন্ড করবে, মানে স্পেসিফিক হিটটা উইল বি ডিফারেন্ট ফর ডিফাইন্ড কন্ডিশনস. উই হ্যাভ টু স্পেসিফিক কন্ডিশন. ওয়ান ইজ স্পেসিফিক heat at constant pressure, so we call this Cp, and another is specific heat at constant volume. This already you know, this is Cp, so suffix b for constant volume, constant. So this we will write at dq dt at constant pressure, this we will write at dq dt constant volume. These two definition you already know. So specific heat is the amount of heat required to raise the temperature of 1 gram mole. 1 gram mole 1 ডিগ্রি টেম্পারেচার বাড়াতে যা হিট লাগে সেটা হচ্ছে স্পেসিফিক হিট. নাও এখানে দুটো কন্ডিশনে এটা স্টাডি করব. একটা হচ্ছে এই যে টেম্পারেচারটা বাড়বে হিট দেওয়ার ফলে, এই হিটটা কি কন্ডিশনে দিচ্ছি তার উপরে ডিপেন্ড করে স্পেসিফিক হিটগুলো আলাদা আলাদা হয়. ঠিক আছে, যেমন একটা কনস্ট্যান্ট প্রেশার হলে এটাকে আমরা বলি সিপি, কনস্ট্যান্ট ভলিউম হলে এটাকে বলি আমরা সিবি. So this Cp and Cb has defined value in case of gas, solid or liquid. Okay. Now from first law of thermodynamics, we say from first law of thermodynamics, suppose dq amount of heat is given. So this heat is given to a substance. So there will be two parts how this heat will be utilized. So there will be two parts. One is internal energy will change. So we call this changing internal energy as due. So due to this application of heat, or when heat is added to the system, there will be two ways this heat will be utilized. One is the internal energy will change, and another is some work will be done. So okay, so if dB is the change in volume, change in volume at constant P, at P constant, so we'll have work done as PdV. This we know. Okay, so from first law of so we will have this relation dq equal to du plus PdV. This we know, thermodynamics relation. This is the internal energy part, this is the work done part. So if at constant volume, what we will have, Cv equal to dq dt at constant volume. So if constant volume, this part will be 0, so this will be simply du dt b from this, and at constant p, Cp will be dq dt at p. So this relation already you know from earlier classes from thermodynamics. Okay, now this Cp and Cv are different, widely it differs in case of liquid or mainly for gases. This Cp and Cv are widely defined for gases, but for solids Cp are very close to Cv, because there is very little change of volume due to change in pressure or like that. So Cp almost close to Cv. So generally we consider both are equal, and we say specific heat of solids in general, but this will be mainly, you should remember that we will be finding out the specific heat at constant volume. We will be dealing with this Cv. Okay, now so we will be working with constant volumes. Now if constant volume is constant, then what will happen? PdV will be 0. So all the heat will be utilized. So all the heat will be utilized to increase or change in internal energy du. So here heat energy will be utilized for changing the internal energy of the lattice. Okay, so now change in internal energy du can occurs in two way. So এখানে দুইভাবে এই ইন্টারনাল এনার্জি চেঞ্জ হতে পারে। একটা হচ্ছে কি, একটা হচ্ছে atoms free to vibrate about their equilibrium position, they vibrates more vigorously, মানে আরো বেশি করে ভাইব্রেশন হবে, তার এনার্জিটা, ভাইব্রেশনের এনার্জিটা বেড়ে যাবে। ঠিক আছে, দিস উইল contribute to temperature rise. This will contribute to temperature rise. And other is in case of metals or semiconductors, in addition there will be free electron or electron carrier will be there, electron and hole, so they may get thermally excited. Okay, they may get thermally excited and contribute to specific heat. So there may be two contribution to the total rise in temperature, or ultimately we say that specific heat. So one is the atomic contribution, atomic vibration contribution, and other is the electronic contribution. So the two contribution have two defined names. The first contribution due to atomic vibration is called lattice specific heat contribution, that is the contribution due to the lattice vibration. So we have studied already lattice vibration, the vibration of collective vibration of all the atoms. So it is lattice specific heat. So we can write it like this, we can call it CL or C lattice. Okay, we can call it C lattice. And other is electronic contribution contribution, which is called electronic specific heat. So we can call it C electronic. So total specific heat will consist of two parts for the solid. One will be lattice and other will be due to electron. Okay, so two components will be there. Okay, now in this unit or in this topic, we will mainly be concerned with the lattice specific heat. So we will not consider electronic specific. So mainly we will be considering with the insulator or normal solid where there is a very low conductivity. Electron, free electron are negligible. Okay, so we will be mainly considering with the insulating solid. So we will be not or insulator or whatever material we consider, we will ignore the electronic contribution. So here we will say the specific heat of solid is mainly due to the lattice heat capacity. So in the next slide we will study about different theories that are given to find the expression for heat capacity. Now another term is, here we have always used a specific like this. So specific. Now another term is used, you should remember, that is heat capacity. So specific has a specific name. So what is heat capacity? Heat capacity is general. It is actually, what is this? This is heat required to raise the temperature by 1 degree for entire mass or volume. If you take any certain volume or certain mass, so whatever heat you have to give to that mass or volume or the entire substance to rise it 1 degree. So this is obviously a extrinsic property because it depends on mass and volume. If you increase the mass, obviously heat required will be more, but specific heat capacity is per unit. So how we define the specific? So specific in case of, it will be per unit mass or volume. Okay, so specific heat is heat capacity per unit mass or volume. Okay, so this is similar to the density type. Okay, and this is normal like mass or volume type. So heat capacity is general. So we can also sometimes use term heat capacity. So lattice heat capacity. So this will means the entire substance, whatever the volume or mass, you have to consider number of atoms within the volume B. So here you have to consider A and B, etc. And here we will be using per unit volume 1 by B like this. Okay, or we will consider number density like this. Okay, so here specific heat is heat capacity per unit mass or volume. So you have to remember this definition also. Okay, so in next slide we will be studying the lattice heat capacity. First we will study about classical theory that is given earlier at the very beginning. Classical theory was there. So classical theory of lattice heat capacity. Then there comes the quantum theory. So this will overcome the classical. There is some drawbacks of the classical theory or some discrepancy, and this will be overcome by the quantum theory. So okay, so let's go to the next